Hi, my name is Abhinay Adi, and my ID is 11450111. So today I'm going to give you a presentation about my project, recurrent neural networks for sequence data. Okay, starting with the first part is the description about time series dataset. I'm going to explain what is a dataset, and what are the columns and rows in it, and how are we going to use it to describe our analysis. So the dataset has been taken from Kaggle website, and you can see the link here. And the dataset contains around 2,200 rows and 143 columns, and it contains data about football players, like all the stats regarding them, so that we can use them to analyze and extract meaningful information such as who is the best player and which player has contributed to the team. And we are also going to use the data to measure to improve other business performances, like to increase ticket sales and limitation of the place, etc. So this is going to be a big process, and I'm going to explain each step in detail in the next 20 minutes. Coming to part 2, we are going to describe about the algorithm we use. We use RNN. It's a simple recurrent neural network, and we are going to also use sine wave data in it. Okay, coming to RNN, in the RNN we are going to use one hidden vector, which we are representing it with a letter H. It is used to describe a neural network with a single hidden layer, and this algorithm is also referred as uh, ILM RNN, in remembrance of Professor Jeffrey Illman to his contributions to this RNN. Okay, coming to the process, as you can see here in the picture, there is an input layer and there is an output layer, and there are two hidden layers where there are mappings between the data and the input layer and output layer. In the second picture, we can see the exact functioning. So we pass the input to the function, and the input function will retrieve the output value y. So this is in briefly about recurrent neural network. Yeah, and after this process, this is the basic process. And after this, we are going to develop time series generator, and we have used Jupyter Notebook to cover all these topics. We have used the practical implementation has been done on Jupyter Notebook using Python 3.1, and we have used several libraries like Pandas, NumPy for arrays and records, and Pandas for mathematical operations, and Matplotlib for mapping different visualizations, graphs, etc. And we also use neural network algorithms like TensorFlow and Keras. Yeah. So we have generated data, as you can see in screenshot below, that we have generated data. The second step is to make sine waves. To begin, we will use NumPy space function. This is used a lot, quite a bit in the data science and data and machine learning. Here we are going to we are going to pass the function a value, so that to split 768 new pieces of information into a range of 050 values. So I mean from 0 to 50 values, the function is going to split the values. Okay, so and we'll completely populate data with relevant data df, like, and the sign values, as we know, is varies from -1 to 1, and all the values may take one value from either from value from -1 to 1, and x is the index and y is the information being indexed. Coming to how data is used for training and testing, we have splitted the data into train and test. So first we'll train the model, and then we'll test the model and to see what's the accuracy of a model, and then again fine tune the model according to our error value. As you can see here, we have used the function to like it's we have used train it as 80% and test data as 20%, as it's a basic norm, and it will make sure that the error is very less. So as you can see, we have given all those screenshots where our working can be seen. So we have used different, like we have spitted data here. How we have spitted data also has been shown here. So it can be used for reference future reference. As you can see, these are examples of how the data looks. The top 5 values using it. You can see the train data are top 5 values and test data has top 5 values. So here the data test and train data are randomly generated. So there is no bias in our model. Yeah. Coming to build and train, as we know, the construction of recurrent model is the first step. We'll be using Keras so that in sequential API, since it's a basic norm that this will result in good network. So the first layer will be layer will be named model, and the second sub network in our single layer vanilla RNN is feed forward network. I guess it's like, as you can see, this is the one. In the first layer we were talking of Keras, and second layer this one. So the input is provided as two-dimensional sequence, the length of which is determined by first step and subsequent steps. As you can see, as we have discussed earlier, the values will be ranging from -50 to +50. Our values will be taking one of these values from -50 to +50. It will not exceed this range. And the values are a combination of continuous data points and floating point numbers. So it could be 1.11, 1.22. It will be anything. It's not like integers. We can use any. It will take any of the values. And MSC is the optimal chord function, minimum square error. So to get the error and to rectify, we are using MSC, the minimum square error, where we'll square the errors and then we'll average it and then we'll take the square root. So this is one of the best methods of calculating the error, as there could be both negative and positive values in it. Yeah, as you can see, the steps I've discussed above can be seen here, how it has been implemented. Yeah, and for train and fit, we are using the most popular technique known as fit generator to train the model. It is necessary, like to train a model using fit generator, the data should be entered into chunks. A time series generator will be used, and we'll be using TS generator and epoch parameters. The training data is partitioned before a mode is trained. We have, like, as you can see in the picture below, using these steps, we have completed one period of tuning data post injection. After we are done training the model that is part of the trained data set, we are left with something that we call an epoch. So epoch is generally like it's used for error calculation, and we'll collect the epoch first, and then we'll again use the loss function and we calculate loss function and everything. So first we finish the training after 5 epochs and 770 iterations, and after we done the experiment, our loss, our total loss was very less. It was around 0.0042. So it's almost negligible. So when we tested, it was very good. Yeah, we fetched good results. And coming to model evaluation, so after we testing the data, we need to evaluate the model. We need to check whether it's working good for practical real world data or just theoretical. So we have used single example. So in this experiment, so here we collected. So as you can see here, we recommend at least using 50 points with the first submission, so that the sample size consists of 760 data points and sum of which is 250 characters. So this is as I think in the screenshot mentioned below, we have represented how we did, how we evaluated, how we normalized data. Everything you can be seen here. So in the graph, the actual value is shown is blue, while the predicted value is shown in yellow. So as you can see, they both are intersecting. So I think the results were quite good. Yeah. And coming to part 3, so we have used RNN LSTM neural network. So so LSTM means long short-term memory neural network. It was created by German scientist Sepp Hochster and Jürgen Schmidt Huber in the late 20th century to deal with vanishing gradient issue. To solve the problem, they came up with this model. With its robot design, the LSTM network can withstand a defect and stop it from propagating across the network layers. And the neural network can keep on learning throughout several time steps. As you can see here, there is hidden thread HHT-1 and this memory here. So the input will be passed to the forget gate and it goes through this and input get everything and we'll get the output. Cell, st cell C state and gates are essential concepts in an LSTM. The LSTM, as we know, relies heavily on two concepts, cell state and gates. To solve problem with vanishing gradients in short-term memory, LSTM may make for some limitations of the simple RNN. Along with the H state, also known as N state, in LSTM cell also processes a C state, also known as cell state. So, in short, without penalty, one cell state may be utilized in any future time step without penalty, provided that information is still great and that is relevant and meaningful. Yeah, this is a perfect diagram to represent how we are, how the LSTM model works. So you pass the input here and the hidden layer here. You can see it's loops in itself, and you can see a combination of cells here. So the output of one is again passed to input of other, and here you can see LSTM cell. Like one of the like one part each LSTM consists of different multiple cells, and the structure of LSTM cell has been given here. You can see for one input there is one hidden layer, and you can see the current. Yeah. And coming to shortcut of a cell state, information in the cell is remembered by cell state step each time. So the information we pass, it's remembered at each step. So after each step, it's again goes to the next cell. So it's independent of the cell's position in time sequence. So every possible instance of a local minimum bias plot, record, weight, etc. In the near future, near like still we scientists are working on it. Neural networks will be available in a number of forms, and they will all perform better than do now. And at the conclusion, we can say that we will have an assemblage of neural networks. As you can see here, there will be an assemblage of neural networks. And coming to, this is the algorithm, like how LSTM works. The first step, what it does is it forgets the gate. Then after it will establish a preferable to return information representing CT-1 state of cell. Like the previous state, it will capture and see it will decide whether delete it or represent it. So it is given by mathematical function f of t equal to sigma of WF. So this is the mathematical function. Okay. And coming to step 2, it's void that it's that GAT can determine. Now we determine the relevant data HT minus 1 and outputs XT that should be integrated into the updated C state of the cell. As you can see here, we have also two different formulas. So we are using here tan H formula. So tan H is hyperbolic functions. So we are using here so that we'll get the values in a given range. And coming to step 3, in this layer, we'll activate the output gate, and then we'll calculate a new state, uh, new current cells C equal to FT into CT minus 1 plus ID into C. And coming to output gate, we'll select the HT minus 1 XT inputs that should be utilized in conjunction with the updated cell state to produce HT hidden state at the time step T. So as we can see, there are multiple mathematical formulas here. Each one will do one thing and we'll pass this to other one. So we use all these parameters to for the LSTM cells to perform. So this is the effective fix for vanishing gradient issue. The expected value of the network is y. The neural network forecast of y dash is also expected. So the difference between the actual output and desired output y dash minus 1 is the value, is the loss function. The damage is severe, so that a little amount was now the network expects several false. So as we see, we have reduced the likelihood of making mistakes. As you can see here, here is a working diagram of how feed forward neural network works using back propagation. You can see this is a x in t minus 1 node. We are passing it to a hidden layers, and there is one function running behind them, like it will map the input to the hidden layer, and again from input layer to the output layer there is again a map. So this is how this works. And so in short, these are how the working pictures of how RNN, LSTM and GRE works. As you can see, RNN is very simple of three of them, but LSTM and GR are pretty complex, but they are also they're also proof they do not have, they're also recipe, they will not be having so many errors. They will help the scientists to work well without getting, like, the model too complex, and it would tackle most type of data, unlike RNN where we can only use single dimensional data. So here we are talking about gradient descent and back propagation. So here I'm going to explain how this is being done. So as you can see here, first there will be weights associated to each node from the input function to the hidden layer, and each one has will be given some random weight at the beginning, and after some iterations they'll again back propagate, like we'll see the error, like what is the difference between the actual value and the expected value, and we again backtrack and we'll set the weights for W1, W2 and so on, so that we'll get the correct output. This way the neural networks work, like it's all back propagation, like it works like human cells. So back propagation is being used to get the answers. And coming to, yeah, limitations, as I said earlier, simple RNN is very basic neural network. It will not work for many types of data. It will just work for simple data. It cannot capture the details in the huge data and data with multi-dimensional. Just like any other real learning method, it has inherent limitations to areas for development. So some of the main drawbacks of RNN are it's the issue of gradient either vanishing or growing in size. So the gradient is not being used correctly, so it's on the extreme ends. And one more issue is it's sluggish, like it's very slow, and it has many, it's prone to many errors. And third issue is that RNNs can't be stacked, like it cannot be used one with one another, unlike LSTM where we are using multiple cells at a time. And coming to the training RNNs, let's examine the reasons for the development. RNNs are able to learn from a sequence of data. Thus, a recurrent model is required if you want the model to keep track of chronological sequence of events. As you can see here, training RNN, we have used multiple pictures here. So training RNN, it consists of how it's developed. So you can see the sigmoid function, RELU function, tan HX function, and we can see the issue of fading or bursting gradients. So this is one of the issue, and inflated gradients is one more issue. These are all the main drawbacks of RNN, and we are explaining in this chapter how the errors can be. We are explaining the errors, and we are also explaining what is the main issue behind it. And as we said earlier, RNNs are not stackable, and they are slow and difficult training methods. For small data, it works fine. Like it will get results in a achievable time. But as the data grows, the time taken to analysis also gets exponential, and it may sometimes take days or years to get the analysis results. Okay, so here we have also answered some of the questions like how LSTM network can provide powerful solutions to both gradient problems, like for both vanishing and exploding, and address limitations of simple RNN neural network. So here we have used how the mathematical, we have used mathematics to mathematical integration to prove how it has been used. So here we can see the integration. So here we can like solve derivative, like from one step to other step we can all go into it. Can refer this one. Yeah, you can see the working model. Previously we explained it very briefly in the previous chapters, but in this chapter everything will explain detail. We can refer this for any further doubts, like how if you want to know each and every step, this is perfect one. Yeah. So this is how RNN LSTM, how this all works and what are the drawbacks of LNN. We have learned all this in the previous topics. And fourth part, we are going to see how RNN and LSTM works with time series data. As you can see here, we need to bring matplotlib so that we can use this, how the data is evolving. We can see here we'll be using a variant of RNN for time series with dropouts. So the MLB system is hierarchical with several types. The data scaling requires a min-max scaler as well. To put the basic RNN to work, we need some sequence data. I will be making use of stock market information for this purpose. Information abounds in the stock. So yeah, you can see as we have collected data and we have plotted graphs using this data. We can see how the data is basic relationships in the data. so it will morally data perform, and we can clean the data and use data engineering well. Yeah. So as we can see here, we have visualized models performance after training. So the sample is an input sequence of time series, and you can see in each sequence we find 60 individual data points. You may choose from 37 batches, and for each batch, 84 samples are being taken, and sequence may be used for forecasted values that will occur at position 60 in the next sequence. So as you can see here we described everything about the model here, and there is, you can see we have used feature count, we have created time series generator for forecasting, we have visualized models performance after training. So we have performed every step in neural network creation. Yeah. Yeah. And compare network performance. Like based on design and core parameters applied to LSTM neural network in part 3 and the network in part 4, compare their performance. So we we have one popular kind of neural networks with long-term memory is long short-term memory, LSTM RNN. So this features we have compared the two networks performance assessment, and we have seen how long it takes to train a model. Compared to other approaches, what we found out is LSTM performs better on the same data set. So LSTM is clearly the winner in this case. Uh, we can see the model will be configured online training and batch size of one, as opposed to batch training or mini batch training in RNN. Due to this, it is acceptable to predict some dissimilarity in the model fit. Despite tweaking the model using the following settings, we saw little to no noticeable impact in performance. And in the part 7, we have interaction section to introduce the project. So we have given all the details about how this project works, what are the various which we have used, and how RNN works, and how LSTM works. And we have given to conclude project report, like which is the better based on our analysis results. So these are all the conclusions we have given. So for references, we have used the famous blogs of many different YouTube channels, and any data, any articles of famous scientists in the field of ML. So you can refer to us for various results, and we have also written in conclusion project report, so you can study to understand how which is the better of both of them. Yeah. Thank you.